Hello Honors Chem and welcome to online learning. This is going to be fun. We're going to have a good time. Okay, so we've already started talking about the ways that we name organic compounds. One of the first thing we talked about was a system of prefixes. So that is meth for 1, eth for 2, prop for 3, bute for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. That is earlier in your notes. Then we can use the suffixes to tell us the type of bonds or functional groups. So if you remember, an alkane with single bonds ended in ane. So the simplest group of compounds are our straight chain alkanes, methane, ethane, propane, and so forth. We can also use ene for an alkene and ine for an alkyne. Now, those alkenes and alkynes can have their double or triple bonds in more than one location, which we have seen because we have just been drawing isomers, and we know that we can put the double bond in more than one spot. So here we are looking at pentene. And pentene is, of course, 5 carbons in a row. And there are 2 different places we can put the double bond, either here or here. Those are 2 different compounds. So because those are 2 different compounds, they have different properties, and so we have to give them distinctly different names. So the way that we do this is we are just going to number the carbons. So let me get a nice small pen type here. So we're going to number the carbons, and this is starting at carbon number 1, closest to the first point of interest. So the first point of interest is that double bond. That's why I start numbering from the left. This would be 2, 3, 4, and 5. In the picture on the right, same thing. We start closest to the end with the double bond, which is closest to the left. So 1, 2, 3, 4, 5. So what we are noticing is this. On the first structure, the double bond starts on carbon number 1, and in the second structure, it starts on carbon number 2. So they have 2 different names. This first one is called 1-pentene, and this second one is called 2-pentene. So really pretty straightforward. It's the same name that you would expect, pentene, because of 5 carbons with a double bond, and the 1 and the 2 just tell me where that double bond begins. Remember, we always have to think about things in 3 dimensions, so we wouldn't have a 3-pentene because we could just flip that around and it would be the same as 2-pentene. A 4-pentene or a 5-pentene, flip that around, it would be the same as 1-pentene. So just like you've been doing with your isomers up until this point, you really have to think about what they would look like. Now, it is also possible that we can have more than one double or triple bond, and then we go back to those old prefixes of di for 2 and tri for 3 right before that suffix ene or ine. And then, of course, we number the carbons in the same way to show location. So below, we have 6 carbons in a row. And 6 carbons in a row would be hex. We've got 2 double bonds. So we would say hexa, diene. And those 2 double bonds are on carbon number 2 and carbon number 4. So the overall name of this compound is 2,4-hexadiene. When we have a functional group like the ones you've been identifying, we are going to do the exact same thing, numbering the carbons to show the location, starting with the number closest to the first point of interest. So if we look at this first example, the alcohol group that is right here is closest to the left. So I would number 1, 2, 3, 4. So the name of this compound is going to be 2, because that's where my first point of interest is. Then I'm looking at the fact that I have 4 carbons, so 4 is bute, and those carbons are single bonded, so bute-an, and then we have an alcohol group at the end, which ends in -ol. So the full name is 2-butanol. Okay. Looking at the second example. This time our main point of interest is right here, and that is once again closer to the left. So we'll number from the left. 1, 2, 3, 4, 5, 6. Okay, so our point of interest is on carbon number 3, so 3, and then 6 carbons is hex. They are single bonded, so an. And this functional group, if you remember, is an amine, so hexan amine. Now, amines are a little special in that we could put the amino first, and so we could have said 3 amino hexane. And both of those names would be equally correct. Coming down to our next example, here is my point of interest, and this time it is going to be closest to the right. So I'm now going to number closer to the right. 1, 2, 3, 4, 5, 6, 7. So my point of interest is on number 3. And I just said that I had 7 carbons, so that's hept. Those carbons are single bonded to each other, so an. The double bond to the oxygen is separate, so we're looking at single bonds between the carbons to be an. And then finally, this is a ketone, so -one. 3-heptanone is the name of that compound. Okay, everybody so far so good? Right, last one. We have 2 points of interest, right here and right here. And the first one of those is closest to the right, so we will once again number from the right. 1, 2, 3, 4, 5. So we have 2 of the same functional group on 2 and 3. So I'd write 2, 3. And then 5 carbons is pent. They are single bonded to each other, so pentane. I'm going to put that E in there. You'll see why in a second. Because my functional group is an alcohol, but I have 2 of them. So it'd be pentane diol. And we just say pentane diol rather than pentanediol. Just sounds a bit better. So sometimes you'll see we take the extra vowel out if we're going to do a double vowel, and sometimes we put it in if we're going to follow with a consonant. That is not the end of your universe, but I'm obviously going to write the most correct answer for you to see. Okay, so those were all straight chain compounds, and now we're going to look at branched compounds. So a branched compound is really just a main carbon chain with something branched from it. So the longest continuous chain is what we call the parent chain. And that is the longest chain that you can trace out with your finger or pencil on the paper without having to pick your finger up. So when we are looking at these structures below, it's the same structure drawn twice to demonstrate a point. If we look at it too quickly, we might be fooled into thinking that the greatest number of carbons is going straight across here, which would be 6 carbons as it's labeled. However, if we think around corners and we actually think I could go around here, I never had to take my finger off of the iPad. Now I in fact have 7 carbons in a row on this structure on the right. So in this structure here with 7 carbons in a row, that is my parent chain, and as we'll see on the next page, the carbon I did not highlight in yellow becomes a branch. So the main part of the molecule is named for that parent chain, so that is named heptane. And then we treat the branches just like we did the functional groups or the double bond or the triple bond in the previous examples. We use numbers to show location, and then a branch takes the suffix -il, YL. So in this little picture here, now I did this on purpose. On the last page, when I highlighted this chain, I actually numbered it with 1 starting at this end. I kind of lied to you. Because what we want to do is we want to start the numbering closest to the first point of interest, which is right here. So I number from the bottom, in fact, and I've already numbered it here, 1, 2, 3, 4, 5, 6, 7. So my parent chain is hept, and they are single bonded, so heptane. And then over here on carbon number 3, I have a 1 carbon branch. So that 1 carbon branch wasn't included in the parent chain. Prefix for 1 is meth, and the ending is -il to say that it's a branch. And so we would say 3-methyl-heptane. And yes, it really does join together like that, 3-methyl-heptane. Okay, so that all sounds pretty easy, and now I'm going to scare you with the next picture. That is a scary looking picture. Okay, so we've got 2 examples here, example 1 and example 2, and we want to look at how to name these. So what I want you to do in your own time is I want you to take a look at these structures in your Notability, and I want you to try to identify the longest continuous chain. So the longest series of carbons you can highlight with your finger without taking your finger off the paper. If you can get more than 1 with the longest chain, go for the one that has the most little branches attached. That is an official rule, not just something I'm making up. Then look at the branches you have. Maybe circle them with a highlighter of a different color. Number either right to left or left to right, depending on where the first one pops up. And think about what the names of those branches would be. So I want you to have a go at that, try that, and that's actually going to be your little closer assignment, is you are going to send me just this page with your ideas on the name, and then when we pick up on Friday, we will name these together. Okay? Have a great rest of your day.